Welcome to Plutus IAS, and today we are covering Umpolong reaction. Now, the Umpolong reaction is studied under the paper 2 of the UPSC chemistry optional syllabus under the unit synthetic use and reagents. So, the reagent we are talking about today is butyl lithium, and what does butyl lithium has to do with Umpolong effect? That. So Umpalong effect does not belongs to the English. It is not an English word. Umpalong comes from the German word. Is a German word. Is German, whose which literally translates to reversal of reversal of polarity. So that means Umpalong reaction is that kind of reaction where you are changing the polarity of something. You are making something positive to negative, something negative to positive, or positive to negative. These are the things that where we talk about that this refers to Umpalong effect. Now, the Umpalong effect is mostly seen when we are talking about our carbonyl compounds. So we know that carbonyl can undergo resonance and be electrophilic in nature and mostly undergoes through nucleophilic addition reaction because they possess the positive charge. So where does the Umpalong comes into it? What does the Umpalong reaction does? It changes the polarity of this carbon from being positive, from being an electrophilic center to being a nucleophilic center. This entire thing will be termed as your Umpalong effect. Here, for example, this effect is seen when you are taking a, let me switch to slide. This effect is seen when you are having a carbonyl, okay, and you make it react with diethene. Diethene. First, you will remove water and it will form, let's add an H here, and it will form thiacetyl. This thiacetyl, when comes in contact with butyl lithium, this butyl lithium is responsible for the Umpalong effect here. Now you can clearly see here the butyl is nothing but it is negatively charged. So what it does, because of the electronegative difference between the carbon and hydrogen, it attacks this electrophilic hydrogen, and the carbon pull back its electron from the hydrogen, and this leaves with us with a negative charged carbon, which is goes by the name 13 diethane anion. Now, here you can clearly see that the carbon which was initially positive charge has now got complete negative charge. That means its polarity has now been changed from positive to negative, and this was the entire Umpalong effect. Now later on, if you make it react further with, if I bring in any electrophilic reagent, since now it's nucleophilic in nature, it can attack any electrophilic reagent using its negative charge and can add this to itself. Here it will look like this, having R, and when you hydrolyze it, it will convert itself to a ketone or any substituted form that you like. So this entire reaction where we are changing the nature of the carbonyl carbon from positive to negative, this is referred to as your Umpalong effect. Now this effect is very useful for reaction when you want to increase the reactivity of carbonyl, when you specifically want to substitute carbonyl with other groups. Okay, now the question arises, sir, the similar effect can also be seen with if I'm reacting carbonyl with Grignard reagent. Well, yes, you can also see it, but the problem is Grignard reagent has a very limited application in this case, because Grignard reagent has a problem that it cannot attack the sites which are sterically hindered. But BULI, compared to that, It is much more nucleophilic in nature and is a heart center. So the reaction with BULI is much better compared to the Grignard reagent. Hence, the Umpolong effect is mostly discussed and as a major case when you are specifically using alkyl lithium compounds. Otherwise, it is not much as discussed. Okay, so I hope this has now cleared your doubts regarding Umpolong effect, what it does, what is application significance, and why it is different from other kind of organometallic reagents. So I hope if you have any doubts, clear, you can add it to the comment section, or any new video or topic that you want us to cover, you can also add it in the comment section and we'll get back to you. Okay, and thank you for joining us. Keep learning.